Hello everyone, this is Abdul Halim from FlexoMaster. Welcome to my channel, and I would like to teach today the chapter number 3, Flexography and Packaging, where we will continue starting from the subject uh, called trapping. Trapping is a technique of overlapping colors to avoid unsightly gaps created by misregistration. A small variation in the placement of colors called misregistration can be caused by substrate handling and tension problems on the press, and the irregular plate elongation from one color to the next, inaccuracies in plate mounting, plate bounce, and limited register capabilities, especially with the molded rubber plates. A test, a test run called fingerprinting analysis can determine the registration tolerances. Traps are created by spreading or choking graphic elements depending on adjacent colors. When a lighter element appears against a darker background and the lighter color is spread into the darker color, slightly increasing the size of the graphic element. When a darker element appears against a lighter background, the knockout is choked by slightly filling it with the lighter color. Both methods create a small overlap of ink colors called the trap width. This width depends on the thickness and size of the type, the adjacent colors, and the registration capabilities on the press. Script, serif fonts, or small type can be spread or choked only small amounts before the shapes are compromised. In general, light and dark colors allow for greater taps width than colors that are similar. See in the illustration here for trapping, spreading lighter color, and it is a choke lighter color. So this is called spreading and choking. We'll go to the next slide. Overprints and traps. Printing inks on top of each other is called overprinting. In flexography, one ink can be printed on another only after the first has been completely dried or cured. For this reason, flexographic presses use dry trapping, where the printer must allow for drying. For substrate like clay-coated liner or non-absorbent packaging such as polymer film, drying time can be a problem. Overprinting a second color when the first is not dry creates an unattractive blotchy effect often called nail heads, especially on large solids. Excessive trapping can cause such problems and can slow down the printing process. Here we start with the color management slide. The wide variety of substrates, lack of standard ink hues, unique Dotgain characteristics all contribute to the difficulty of communicating and reproducing color by the flexographic process. Color management system with any manufacturer softwares used to ensure color consistency among different input and output devices so that the printed results match originals. Here is the test targets, and we will show you in the next chapter covering fingerprinting analysis. The dot gain in flexography is all printing processes are subject to the unavoidable occurrence known as dot gain. As dots are transferred from film to plate, they tend to grow in size during light exposure. When an ink dot is transferred from plate to the substrate, it can increase in dot once again as the ink spreads during absorption. A dot that began as 50% on film can grow to 51% on the plate and eventually print on a flexographic press as a 65% or greater dot. The fluid ink and compressible plates used in flexography tend to increase dot gain, but it varies according to the type of a press and the substrate. And here is showing that impression of the press, which will also deforming the plates while you are applying the pressure during printing. Even though ink is transferred under relative light pressure in the printing dip, the soft flexo plate deforms, slightly compresses during image transfer. This causes ink to spread, increasing dot gain. Come to the plate durometer, and durometer is the hardness of the plate because harder plates do not compress as much as softer plates. They produce less dot gain. Softer plates, however, transfer solid images are more completely. Dot gain can be minimized by using 0.002 inches to 0.005 inches capping layer surface with a higher durometer than the supporting plate material. Dot gain can also be reduced by mounting the plate with compressible tape or a blanket that absorbs pressure. And is an instrument called a show A hardness to check measure plate hardness, which is called durometer. The image on the left shows the scale measuring a soft plate. On the right is measuring a harder plate. Inks and substrates. A higher viscosity inks will not spread as quickly as one with lower viscosity. The spreading or flow out of a low viscosity flexographic inks occur as it is transferred to the substrate and before it dries, contributing to dot gain. By comparison, offset ink is a thicker paste consistency and is not prone to excessive flow out. The illustration shows here that this is a high viscosity and a low viscosity, and here the different substrates give the dots in film, in coated, uncoated, newsprint, and corrugated substrate. The printing surface or a finish of a substrate also influence dot gain. When ink is applied to smooth, non-absorbent films and coated papers, it tends to spread very little, preserving the dot shape. With more absorbent and irregular printing surface, such as uncoated paper, newsprint, and corrugated liner board, the paper fibers act as a wick, absorbing the fluid ink and causing it to spread beyond the dot shape and pattern. Now we study the halftone and its screen. Throughout its history, flexographic has been quality line art and spot colors on a wide variety of substrates. However, it is the recently improved capability of high quality, economical four-color process as printing that has given flexography an edge over other processes for packaging application. To minimize density jumps in halftone, round dots are preferred. Round dots do not touch with until coverage is nearly 65%. For the symmetrical round dots and 75% for asymmetrical dots. The dot gain is less at these higher coverages and is more easily controlled or compensated for. Here is showing square dot for 50%, stochastic dots at 20%, here asymmetrical dots at 75% here, nearly 75%, symmetrical dots in 65%, and asymmetrical dots reversed at 80%. Screen tints and gradations. Highlights. Most polymer plates are capable of holding a 2% highlight dot if plates are not properly exposed. However, screen tints and highlight dots less than 3% tend to drop out because the small dots of highlight areas are subject to relatively large dot gain. It is important that highlight limitations are discussed with the printer before separations are made. Graditions and vignettes. Flexographic dot gain are on highlights makes it difficult to print fade to white gradation without a harsh break at the highlight edge. When designing images for flexography, it is best to fade off the end of the design rather than to white or place with a border at the highlight end of a vignette. Line screens and cells per inch. Here I am explaining you the screen ruling, which is lines per inch and cells per inch for Anilox rollers and for application. Here is 65 LPI 280 to 360 CPI corrugated box board to print halftone at 45, 55, 65 and 85 LPI is the maximum. 85 LPI skin ruling of a plate, and the Anilox rollers which use 360 to 400 CPI, which use flexographic paper printers printing halftone screen between 65 and 100 LPI. 133 LPI of a plate screening that has to be used Anilox roller of 500 to 600 CPI used in flexible packaging on film substrate is commonly done on 120 to 150 LPI. 150 LPI with plate cells and 800 CPI for analogs, which will print high quality label. Printers have the capability of printing 200 LPI images. Here Anilox cell and halftone screen angle. There are Anilox rollers 30 degrees hexagonal, 45 degree hexagonal and 60-degree hexagonal. These are the engraving of the Anilox roll at one of the three angles. Therefore, to avoid Anilox moire, film or plate screen angle should be at least 7.5 degree away from the Anilox cell angle. Cyan, magenta, yellow and black screen angles should be set at less 15 degrees apart from each other. Here is showing in the illustration. The number of lines per inch on the plate should be not more than 25% of the cells per inch on the analogs. Ideally, the analogs should contain a minimum 4 cells on every halftone dot. Now we come to a step and repeat. We have discussed earlier this is step and repeat process. Nesting images can maximize the plate area and avoid the place seams for step and repeat printing. Layout and imposition software offer step and repeat options for specific repeat lengths and web widths. The next slide will show you the die cutting. After printing, most substrates are cut, folded, scored, sealed or glued off in line in order for packaging to be properly constructed. Die cutting requirements must be exactly specified for both the designer and the printer. A die cut label or folding cartoon must have all the graphical elements in the correct position. Here you have braid boundary, slot lines, all right, die cut boundary, scoring lines, dust flap, here, and this is a glue tab. The more details on die cutting will come in our individual chapter of rotary die cutting. You can definitely see it. Now plate bounce. Plate bounce is a process. Staggering images on the plate can help keep continuous contact between cylinders, minimizing plate bounce. Sometimes it is necessary to place non-printing bearer bars or non-image areas to maintain contact. The process workflow, which shows you, it start from artwork design, then CTP flexo plates, the computer to plates used as a device for imaging the digital plates, then flexo plates processing step, then you start plate mounting on the cylinder, then it goes to the either printing wide web or it goes to the printing narrow web. Then printing wide web is go to lamination or converting into bags or something like this, and it goes to inspection, silhouetting and reminding. What to look for during a press check? This is very important that when you check the press check during press check, what you have to look. Type is the type is sharp, has the weight of the type change with a loop. Look for outline halos. Then registration, are the colors is registered? Make sure colors line up and check areas where inconsistent elongation may have caused misregistration. For a 4-color process with traditional screening, color to color register should not vary by more than single row of halftone dots. Density, color intensity. Is the density of the color appropriate, especially in situation where screen and solids are printing from same cylinder? Is the color strength consistent from side to side? Next, color matching. Do spot color match? Each color should be verified. When appropriate, use color measurement instrument to verify acceptable match. Ink laydown. Is the ink laydown consistent without mottle? Are there pinholes or voids? Okay, under a loop, halftone dots should appear sharp, not slurred. Substrate. Is the width, caliper, and type of substrate are specified? If the substrate is opaque film, is the opacity appropriate? Then external register. Does the print line up with the specified finishing operations such as die cuts, side seals, slots, scores, and glue areas? Request a mock-up container to check accuracy of external register. Inks and impression levels. Look the edges of solids for an outline halo, which is the result of excessive ink or impression pressure. The press operators may be able to relieve some pressure. Okay. Some plates may have spot color inaccuracies that required a plate remake or remount. Dot gain. Dot gain levels should be comparable to those achieved during fingerprint trials. The next slide is UPC and barcoding. Over impression can change the widths of a bars and spaces, potentially making the barcode unreadable. Wind direction. Has the job been installed as a direction on press? If the press is running roll to roll, is the print rewind on the proper direction? Yeah, this has to be checked. So we are finishing here. Thank you very much for giving your valuable time. The chapter number 3 for flexography and packaging, and we will move forward for chapter number 4, and you can comment, and you should watch the next video what it is giving you. And thank you very much, and goodbye. See you next time. Thank you.